Hello friends, welcome to Learner's Planet. Friends, this is our fourth session for trigonometric identities. In the previous session, we did good number of questions based on identities. In this session, I'll be taking more identities, more important identities in fact. So, let's begin this session and do revise the previous session before you come for this session. Now, first of all, let's try this sum. As usual, we'll begin from left hand side and we'll reach right hand side. Now 1 plus cot square theta tan theta by sec square theta, that we have to solve. Now we can use the identity that 1 plus cot square theta is equal to cosec square theta. Okay, so we can directly put the value of 1 plus cot square theta as cosec square theta over here. So it's cosec square theta. Tan theta is what? Sin theta by cos theta, and sec square theta is what? 1 upon cos square theta. Right? So this cos theta and this square is cancelled out, and then cosec square theta can be written as 1 upon sin square theta into this sin theta. Right? So this and this square is cancelled out. So we are left with cos theta by sin theta, that is nothing but cot theta, and that's RHS. Right? So very simple problem. Now friends, this is quite similar problem that we had discussed in the previous session, and I told you that if this sort of problems are there, just multiply and divide the expression inside the square root by its conjugate. That means denominator's conjugate, right? So the first step that I'll start is denominator that is 1 minus sin a. So I'll multiply the entire expression and divide by 1 plus sin a upon 1 plus sin a. And obviously we are starting from left hand side. Now 1 plus sin a into 1 plus sin a, that is 1 plus sin a whole square. And 1 minus sin a into 1 plus sin a will be nothing but 1 minus sin square a. It is a minus b and it is a plus b. So 1 minus sin square a is equal to cos square a. Okay, the entire thing is in square root. So if it comes out of the square root, we will be left with 1 up plus sin a upon cos a, right? Now it is 1 upon cos a plus sin a upon cos a. So that's 1 upon cos a is sec a and sin a by cos a is tan a, right? And that is RHS. Okay, so the problem becomes very simple if you follow this step. Okay, so whenever you see such problem, just follow this step and you'll be getting answer very easily and quickly. Yeah. Friends, further we have an important sum. I just write it over here. It's very, very important. Okay, now we start with LHS. Friends, there are various methods to solve one particular problem. So you can go with any of them. What I do is in this expression, I divide the numerator and denominator by cos theta. So it's sin theta by cos theta plus 1 by cos theta minus 1 upon cos theta by cos theta, that's 1 plus minus 1 upon cos theta plus sin theta upon cos theta. So that is tan theta plus sec theta minus 1 upon, this is tan theta, this is minus sec theta, and this is plus 1. Now we got a new left hand side, right? And now we have to prove this is equal to this. Now as I have discussed in the previous question, there are some questions in which we have to replace the value of 1, right? So in this case, the entire expression is in tan and sec. So what is the relationship between these two? That is 1 plus tan square theta is sec square theta. So what will be the value of 1? That is sec square theta minus tan square theta, right? So that's 1. So I'll put the value of 1 over here in the numerator only. So that's why this problem is important, because you have to like keep certain things in your mind, right? So I just put the value of 1 over here in the numerator. So that is tan theta plus sec theta minus sec square theta minus tan square theta. By in denominator we are having tan theta minus sec theta plus 1. Now we got this is a square minus b square format, so that can be factorized as a minus b into a plus b. So it is tan theta plus sec theta minus sec theta minus tan theta and sec theta plus tan theta. And in the denominator we are having the same thing, that is tan theta minus sec theta plus 1. Now tan theta plus sec theta can be taken as common, so I just take it as common, tan theta plus sec theta. Inside the bracket this is 1 minus sec theta plus tan theta, right? Since there is negative sign outside the bracket, so the sign of the terms will be changed. So it will be 1 minus sec theta plus tan theta, and in the denominator we are having tan theta minus sec theta plus 1. Now just compare these two terms, both of them are same, so we can cancel them. So we are left with tan theta plus sec theta. Now in the right hand side we want the expression in sine and cos. So what I do is I convert tan and sec into sine and cos. Now tan theta is what? Sine theta by cos theta, and sec theta is what? 1 upon cos theta. So if I take LCM, I'll be getting 1 plus sine theta by cos theta, that is right hand side, right? So the problem is simple, but certain things you have to keep in your mind. First of all, to divide the entire expression by cos theta in the numerator and in the denominator, then you have to replace the value of 1 as tan sec square theta minus tan square theta, right? So the problem is important. Just do it 2-3 times. You'll be able to memorize it. Okay. Similarly, friends, this problem can directly be asked in exams, right? So in this case, you just have to put up the value of 1 as sec square theta minus tan square theta, as we have discussed in the previous question, and proceed in the same manner, right? Now let's discuss the next question. Now here, further we start from left hand side. Sin theta plus sec theta whole square and plus cos theta plus cosec theta whole square. So I just open the bracket as a plus b whole square. So that sin square theta plus sec square theta plus 2 sin theta sec theta plus cos square theta plus cosec square theta plus 2 cos theta cosec theta. Now sin square theta plus cos square theta is 1, that we already know. So the identity becomes 1 plus sec square theta plus cosec square theta plus 2 sin theta sec theta plus 2 cos theta cosec theta. Now 1 plus sec square theta plus cosec square theta plus I take 2 as common from these two terms, and this is what? Sin theta by cos theta, that is sec theta is 1 upon cos theta, so it is sin theta by cos theta, and similarly it is cos theta by sin theta, right? So it's 1 plus sec square theta plus cosec square theta plus 2. Now if we take LCM, we'll be getting sin square theta plus cos square theta, that's further 1. So it's 1 upon sin theta cos theta, right? Now it is 1 plus sec square theta plus cosec square theta plus 2 sec theta cosec theta. Now if we can observe, this is a square plus b square plus 2ab. That means it is a plus b whole square, or I can say it is sec theta plus cosec theta whole square. Right? So we got this expression, but in the right hand side we have to prove that it is 1 plus sec theta cosec theta whole square. So the problem can be asked in two ways. Once you are asked about right hand side as this and maybe this, right? So we have proved this. Now we will be proving right hand side as this. So just listen to me carefully. After this step, right? After this step, I just write it over here. It's 1 plus 1 upon cos square theta plus 1 upon sin square theta plus 2 sec theta cosec theta, right? Now if we take LCM of these two, we'll be getting sin square theta plus cos square theta upon sin square theta into cos square theta plus 2 sec theta cosec theta, right? Now further it is 1 plus, this is 1 upon sin square theta cos square theta plus 2 sec theta cosec theta. Sin square theta plus cos square theta is 1. Now this is 1 plus 1 upon sin square theta is cosec square theta, and 1 upon cos square theta is sec square theta plus 2 sec theta cosec theta, right? Now you can observe this is a square plus b square plus 2ab. Here a is 1, so 2 into 1 into sec theta cosec theta, right? So we can write it 1 plus sec theta cosec theta whole square, right? That we had to prove. Okay, so this we have proved, right? Sum is bit lengthy but easy. Just practice it for 2-3 times and you will be able to understand it. Okay, let's take the next problem now. Now in this problem, very simple. Just takes we start with LHS. Take sec square theta as common. So we are left with sec square theta minus 1. Now we know the relationship between sec theta and tan theta, that is sec square theta minus 1 is equal to tan square theta, right? So I just put the value of sec square theta minus 1 as tan square theta, and sec square, instead of sec square theta I can put 1 plus tan square theta, because in right hand side we just want the expression in tan theta. So sec square theta is what? 1 plus tan square theta, and sec square theta minus 1 is equal to tan square theta, right? So if we expand the bracket, it will be tan square theta plus tan 4 theta. That's right hand side. Okay, just 2-step solution. Getting me? Now similarly, let's take this problem. Here we further start with left hand side. It's 2 sec square theta minus sec 4 theta. Now what I do is I take this sec square theta as common, so I'll be left with 2 minus sec square theta. Here I take minus 2 cosec square theta as common, so I'll be left with, I'm sorry, just cosec square theta, so I'll be left with 2 minus cosec square theta, right? So it's sec square theta into 2 minus sec square theta minus cosec square theta, so it's 2 minus cosec square theta. Now it's 1. What I can do, I just say we know that sec square theta minus 1 is equal to tan square theta. So in the left hand side we want the expression to be in cot and tan. So I just try to replace sec square theta into tan square theta. So I just put the value of sec square theta as 1 plus tan square theta. So it's 1 plus tan square theta. Here 2 minus 1 minus tan square theta minus cosec square theta can be written as 1 plus cot square theta. So it's 1 plus cot square theta, and this is 2 minus, instead of cosec square theta I'm putting 1 plus cot square theta, so it's negative sign out of the bracket, so the entire terminologies will be negative. Now this is what? 1 plus tan square theta, and this is 2 minus 1, so it is 1 minus tan square theta. Here 1 plus cot square theta into, this is 1 minus cot square theta. So this is a plus b into a minus b and a plus b into a minus b. So it will be a square minus b square. So it is 1 minus tan 4 theta, and this is minus 1 minus cot 4 theta, right? So it is 1 minus tan 4 theta minus 1 plus cot 4 theta. So it's cot 4 theta minus tan 4 theta, right? So that we had to prove, that is RHS. Okay, just a simple problem, bit lengthy but very simple. I hope you are clear. Now let's take this question. There are two questions involved in this. You can prove it like this or this, right? So further we start with left hand side. Now in the first step we'll take LCM of the expression. So it is sin A plus cos A whole square, multiply this and this, plus sin A minus cos A whole square by, this is a minus b into a plus b format, so it's a square minus b square, right? Now we can open the bracket as a plus b whole square, so it will be sin square a plus cos square a plus 2 sin a cos a. Similarly this is a minus b whole square, so it is a square plus b square minus 2ab, right? And in the denominator we have sin square a minus cos square a. Now this is plus 2 sin a cos a, and this is minus 2 sin a cos a, so they are cancelled. Now sin square a plus cos square a is 1 and sin square a plus cos square is 1. So we are having 2 upon sin square a minus cos square a. That was the first part of the question. So this is 2 upon sin square a minus cos square that we have proved. Now for the second part, just observe carefully that there is no cos square a in this part, right? So what I do is I convert cos square a to sin square a. So what I can do is 2 upon sin square a minus 1 minus sin square a. That is the value of cos square a. So what I'll be getting, it's 2 upon 2 sin square a minus 1, right? That is also the other part, right? So the problem is just very simple. Just take LCM and proceed. No complications are there. Okay, I hope you are clear. Now let's see this problem. We start with further left hand side. Sin theta minus 2 sin cube theta. I take sin theta as common. Then I am left with 1 minus 2 sin square theta. And from the denominator, 2 cos cube theta minus cos theta, I take cos theta as common. So it's 2 cos square theta minus 1, right? Now what? In the numerator, what I do, instead of the sin square theta, I write down cos square theta. Or I convert the sin square theta to cos square theta. So it's sin theta 1 minus 2, 1 minus cos square theta by cos theta 2 cos square theta minus 1. So it's sin theta 1 minus 2 plus 2 cos square theta upon cos theta into 2 cos square theta minus 1, right? So that is sin theta. This is what? Minus 1 plus 2 cos square theta, right? So it's minus 1 plus, or we can say 2 cos square theta minus 1, or in the denominator this is cos theta into 2 cos square theta minus 1. So these two are cancelled. So this is what? Tan theta that we want for our right hand side. Okay, so pretty simple problem. Just you have to use the relationship of sin square theta plus cos square theta as 1.